Let's take it up a notch here and do a more complicated example. In this case, we're not told the values of j and k. We're going to have to calculate the values of j and k. It's not a lot harder. As you can see in this figure, I know that j is always going to contain a 1. So I can go ahead and show the value of j. J is going to be 1 for the entire duration of this problem. So that is relatively easy. But now I see that k is going to be received from the value of q. So whatever k or whatever q contains, that's going to be copied into k. So I'm going to see that this is equal to q, and so whatever is in k or whatever is in q is going to be copied up into k. Okay, well, before the first active edge, q contains a 0, and therefore k also contains a 0. And that's up until the very first edge. Now, at the first active edge of the clock, I want to look at what is the value of j and the value of k just an instant before the active edge. So right before the active edge, j contained a 1 and k contained a q, or k contained a 0. And so therefore that's the set configuration, and therefore this is going to go up to 1, and it's going to stay there until the next active clock edge. And guess what? The same exact thing is going to happen to k as well. K will always mirror whatever happens to Q. Now, just an instant before the next clock edge, J contains a 1 and K contains a 1, so this is going to be a toggle. Now, you can see why it's so important to say what is the value of K just before the clock edge, because of course it can transition right at the clock edge. You know, here it's a 0, here it's a 1, but I want to know right before the clock edge. So right before the clock edge it contained a 1, that's the toggle, so now Q is going to drop down and it's going to stay at 0. And the same thing is going to happen to K. What happens next? Let's see. We see that right before the clock edge we get a 1 and we get a 0. That's going to be a set, and set is going to go up to 1 and it's going to stay there, and K is going to go up to 1 and it's going to stay there. And really what we found now is that we've entered into a repeating pattern, and that happens sometimes in sequential devices where we're going to toggle back and forth or alternate back and forth between a set and a toggle, because this contains a 1 and a 1 yields a toggle. We're going to toggle Q and it's going to go down to here. It's going to be copied into K, that's going to go down to here. A 1 and a 0 gives us a set. Set is going to go up to 1, it's going to stay there. K is going to do the same thing, go up to 1 and stay there. Then we're going to get a 1 and a 1 yields a toggle. Go down to 0, stay there. Go down to 0, stay there. We get a 1 and a 0, and that's going to be a set. And set goes up to 1 and it stays there, and this goes up to 1 and it stays there. Now, one thing to notice is that because the value of K depended upon the value of Q, I had to do this one clock cycle at a time. In the previous example, we were able to get away with, perhaps in some cases, going the full duration to figure out set, toggle, hold, reset, and so forth, and then fill in Q. But here, because Q feeds back into K, we have to do it one clock cycle at a time. Now we can go one step even further, and that is to show two flip-flops at the same time. So here, this is about the most complicated example that I could imagine having for this class, at least for this lesson. Let's see, we've got two different flip-flops. I've numbered this one number 0, and I've numbered this one number 1. So you can see that I've identified J0. For example, J0 is here, K0 is here, Q0 and Q0 bar. You might wonder, what is the value of J0? Let me erase these circles just to keep things as clean as possible. What is the value of J0? Well, I'm going to route that back. Oh, that comes from Q1. So Q1 is going into J0. Well, I'm going to make a note of that right down here. J0 is equal to Q1. What is the value of K0? Well, K0 is coming from Q1 bar. And so I'll write that here. This is Q1 bar. What is the value of J1? Well, J1 is coming from Q0 bar. So J1, if I scroll down here, J1 equals Q0 bar. And what is the value of K1? Well, K1 is coming from Q0. And so I can write that here. This is equal to Q0. And actually, once I've identified the functions that go into J and K for each flip-flop, I don't need the circuit diagram anymore. I can see here, I do see a problem here, and that is that I've shown the circuit diagram with active rising edges, and I've shown the timing diagram with active falling edges. To make things line up, I'm gonna show this one with bubbles here. And I apologize if you were confused by that if you did the problem first, but that's easier than changing where the dotted lines all are. So I'll assume that these are both active falling edge signals, and now I can scroll that off the top of the screen because I don't need it anymore. It turns out that all I need is the information that's shown here as to what's in J0, K0, J1, and K1. Now you'll notice that in the beginning here I was told that Q0 is a 0 for its initial value, and Q1 is a 0 for its initial value. Okay, well I can fill in what I know about J0. So J0 equals Q1. Q1 is a 0, so therefore J0 is a 0. K0 is Q1 bar, so therefore that's a 1. Down here, J1 is Q0 bar, so that's going to be a 1. And K1 is Q0, so that's going to be a 0. So here I can see that right before the active clock edge I have a 0 and I have a 1, and then down here I have a 1 and I have a 0. So that means that Q0 is going to be subject to a reset. These two 0 and 1 right here is going to give me a reset. Well, it was already a 0, so the reset really isn't going to do anything, it's just going to stay at 0. And then down here, a 1 and a 0, a 1 here and a 0 here is going to give me a set. And so Q1 is going to go to 1, and it's going to stay there until the next active clock edge. Now, you might need to play this video a couple of times to be able to see the pattern of what's going on here. But the next thing up is I'm going to figure out what is J and K in the next clock cycle. Okay, well, J0 is equal to Q1, but Q1 just went to 1. So therefore, J0 is going to go to 1, and it's going to stay there for this clock period. And K is always K0 is always the opposite of J0. These two are an opposite pair. So when one goes up, the other one goes down, and vice versa. Down here, since J1 and K1 are functions of Q0, and since Q0 didn't change, these aren't going to change either. That was a little sloppy, and these aren't going to change either. So we're going to see that this is still going to be a 1, and it's still going to be a 0, and this is still going to be in set configuration, so that's going to carry on in the 1 state. But up here now, this is a 1, and this is a 0. A 1 and a 0 is also a set. Oops. So that's also going to be a set configuration, and now this one's going to go up to a 1, and it's going to stay in the 1 configuration. Okay, so let's go ahead and do it again. J and K. Now Q0 changed, so that means that down here these two are going to change. These are going to go over here like this, and it's going to go up like this. But Q1 did not change, so these two are not going to change. Okay, we still have a 1 and a 0, and that's still going to give us a set, so this one's going to stay in the 1 orientation. Down here, though, this is a 0 and a 1. That's a reset, so this is going to go back down to 0, and it's going to stay there. And at this point, it becomes fairly mechanical. The thing that changed was Q1, so therefore these inputs are going to change. This is going to change to here. Q0 did not change, so this is going to stay the same. Let's see, this is a 0 and a 1. That's going to give us a reset, so this is going to go to 0 and stay there. This is a 0 and a 1, so that's going to be a set. Oh, did I make a mistake? 0 and a 1 is a reset. Sorry about that. 0 and a 1 is a reset, so this will stay here. And then, let's see, the one that changed was Q0, so these inputs are going to change like this. These inputs are going to remain the same. 0 and a 1. That's still going to give me another reset, and that's going to stay low. Down here, a 1 and a 0, that's going to give me a set. So this one's going to go up and it's going to go over. The one that changed was Q1, so Q1 is here. The greatest danger in solving one of these problems is that you can kind of get lost in the weeds. You know, you're in the middle of a problem and you kind of lose track of where you are and what you've done. Every once in a while you kind of have to sort of reboot your thought process and make sure that you're still on the same page that you were on before. So I'm going to have a 1 and a 0. That just happened to me. And so this one's going to be in its set configuration. That's going to bring it high. And this is going to be in its set configuration that's going to keep it high. The one that changed was Q0, so these two are going to flop like this. But these two are going to remain unchanged. 1 and a 0 is going to give me a set. It's going to stay at 1. And then a 0 and a 1 is going to give me a reset. And this is going to go to 0, and it's going to stay there. Now here's a really interesting thing about this. If I look at the values of Q0, so let me go ahead and fill in the values of Q0. Here's a 0, a 0, a 1, a 1, a 0, a 0, a 1, a 1. If I do the same thing for Q2, 0, 1, 1, 0, 0, 1, 1, 0. And if I take them as a pair, then here you can see I have a 0 and a 0. And then I have a 0 and a 1. A 1 and a 1, a 1 and a 0, and then the pattern repeats. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. This is what's known as modulus 4 or 2-bit gray code. It turns out that I designed this circuit to give a particular pattern of zeros and ones on the two outputs. And in fact, that's what we've observed, is that we're getting the desired pattern. You might say, hey, how can I design a circuit to give me exactly the pattern of zeros and ones that I want? That'll be the subject of the next lesson.